Hi, everyone. My thesis project is focused on the neuron circuits underlying the sodium consumption. So people have paid enormous attention to the calorie intake from fat and sugar. However, every day we are consuming twice of the recommended amount of sodium, and this fact has been ignored with huge consequences. Food scientists have worked for decades and they developed successful artificial sweeteners. However, there is no substitute for sodium. So the current approach to reduce the sodium intake is to add potassium into the table salt, and these make the food less tasty. My project aims to solve this overconsumption problem of sodium with more efficient method. And I'll introduce you to a newly found brain circuits and also approach this problem with a different strategy. So sodium is very unique because the sodium taste perception is based on our internal state and determined by how much sodium is in our body. So just imagine ocean water. It has a lot of high sodium. And if you taste it, it's bitter. And I guess you don't like it. However, after you enjoy the whole day on the beach, you sweat a lot. And at that time, you try again. And I promise this time it will not be as bad as before. So there is a change of taste valence of the sodium from disliking to liking based on your internal state, and this has drawn my attention. We have identified a cluster of neurons in the brain that is sensitive to the amount of sodium in our body. So the mice, like human, when it's thirsty and it didn't like the ocean water like human. However, if we artificially activated these neurons, the mice will suddenly like the high sodium concentrations. And also, if the mice are sodium depleted, they crave for sodium, and then we inhibit these neuron clusters with drug, and the mice will dislike the sodium now. So in other words, it means that with manipulation of these neurons, we can change our perception of sodium without changing the exact amount in the food. And what is more interesting is these neurons are located outside of the blood-brain barrier, and so this remains huge potential for the drug delivery process. What is more interesting in my research is these neurons also express important immune receptors, and this is the first time we can link the inflammation together with the sodium consumption. We observe the inflammation level will increase when the mice are in sodium imbalance, and also when we decrease the inflammation level, the mice will spontaneously reject the sodium consumption. So this remains a huge potential for us to develop surgical tools for the sodium-related disorders. Thank you so much.